For 400 years, we thought we understood what a moon was. A rock, a frozen ball of ice and dust, something solid, ancient, carved by impacts and gravity into a predictable shape, orbiting a planet in predictable silence. That was the definition. That was the rule. Then the James Webb Space Telescope pointed its golden mirrors at the outer planets of our solar system and broke everything we thought we knew. What it found wasn't rock, it wasn't ice, it was gas. Enormous, swirling, atmospheric bodies orbiting planets like moons, behaving like moons, but composed like something that has no right to exist at that size, at that distance, in that configuration. Bodies that planetary scientists had never predicted. Bodies that our best models of solar system formation said simply should not be there. So how are they there? And what does their existence mean for every other moon, planet, and solar system we've ever cataloged? There's a particular kind of silence that comes after a discovery that changes everything. I've read about it in the journals of astronomers, in the lab notes of mission scientists. That moment when the data arrives and nobody speaks, because nobody yet has the words. That's where we are right now with what Webb has shown us. My name is Captain Vega, and I've spent years following the most unsettling surprises the cosmos has to offer. This one may be the strangest yet. To understand why this discovery matters so deeply, we need to go back to the beginning, not of the universe, but of our understanding of moons themselves. When Galileo coned his primitive telescope towards Jupiter in January 1610, he spotted 4 points of light that moved. Night after night, they shifted position.
He realized they were orbiting Jupiter, not the Earth, not the Sun. They were moons of another world. It was one of the most revolutionary observations in the history of science, and it helped overturn the geocentric model of the cosmos entirely. From that moment forward, moons were understood as a category of object defined by a simple rule. They orbit planets, they are smaller than planets, and they are solid. Even the icy moons of the outer solar system, Europa, Ganymede, Titan, Triton, followed this basic template. Solid surface, defined shape, a world you could, in principle, stand on. Titan, Saturn's largest moon, complicated things somewhat. It has a dense nitrogen atmosphere, lakes of liquid methane, and weather patterns. But underneath all of that atmosphere, there is a solid, icy body. The atmosphere is a coating. The solid world beneath is still the moon itself. What Webb has detected is something categorically different. In the outer reaches of the solar system, and even more remarkably in observations of exoplanetary systems beyond our own, Webb's infrared instruments have identified bodies orbiting planets that appear to have no solid surface at all, or at best an ambiguous one far too small to account for the gravitational signature these objects produce. They are primarily gaseous, dense, layered atmospheric structures behaving as coherent orbital bodies. Moons by orbital definition, but composed of material we associate with gas giants, not natural satellites.
The leading interpretation, proposed by researchers analyzing Webb's near-infrared and mid-infrared data, is that these objects represent a previously unknown category, subplanetary gaseous bodies captured or formed in orbit around larger planets, retaining their gaseous envelope because of specific pressure and temperature conditions in their orbital zone that were never predicted by standard planetary formation models. In simpler terms, the universe made a type of moon that our textbooks said was impossible, and it did so in multiple locations, which means it's not a fluke, it's a process. If these kinds of discoveries are the reason you watch documentaries, the moments where science genuinely surprises itself, then this channel is the place for you. Every investigation here follows the universe wherever it leads, no matter how strange that turns out to be. Now, before we go further, I want to be careful here, because this is a frontier, and frontiers are places where interpretation is contested and caution is essential. There are scientists who are convinced by the Webb data and argue these gaseous bodies are real, stable orbital structures representing a new class of solar system object. There are others who propose that what Webb is detecting are not true gaseous moons at all, but rather extended atmospheric clouds or plasma halos associated with existing solid moons, essentially very thick, very large exospheres that Webb's sensitivity is capturing for the first time. This second interpretation is significant because Webb is the most sensitive space telescope ever built. It can detect atmospheric signals that were completely invisible to Hubble, to Spitzer, to every instrument that came before.
It's entirely possible that what we're seeing has always existed around known moons. We simply lack the instruments to detect it. And that possibility is, in its own way, just as extraordinary, because it would mean that our solar system has always contained these vast atmospheric structures, silently surrounding moons we thought we understood, and we never knew. The question of formation is where the debate becomes most intense. Standard planetary formation theory, the core accretion model, explains how planets and moons form from a spinning disk of gas and dust around a young star. In this model, solid cores form first, then, for gas giants, gravity pulls in surrounding gas to create the massive atmospheres of Jupiter, Saturn, Uranus, and Neptune. Moons form from leftover material in a smaller disk around each planet, and they form primarily as solid or icy bodies. The gas in the system dissipates relatively quickly. There's no mechanism in the standard model that would leave a moon-sized body primarily composed of gas, unless something unusual happened. One hypothesis gaining traction is the capture model. In this scenario, the early solar system was a far more chaotic environment than the one we inhabit today. Subplanetary gaseous bodies, structures that never fully collapsed into solid cores, could have existed in the early outer solar system and been gravitationally captured by the gas giants before the surrounding gas disk dissipated. If the timing was right and the capture geometry was correct, such a body could have settled into a stable orbit and remained gaseous. It's a fascinating idea, and it requires the early solar system to have been stranger and more violent than our models have traditionally assumed.
And here is where the Webb discoveries become truly transformative, because they don't just challenge our understanding of our own solar system, they challenge our models of every solar system everywhere. Webb's deep field observations of distant star systems have identified candidate gaseous orbital bodies around exoplanets as well. These are harder to characterize with certainty at those distances, but the spectroscopic signatures Webb can extract from transiting bodies, measuring what wavelengths of light are absorbed as an object crosses in front of its star, are consistent with what we're seeing in our own system. If gaseous moons are a universal phenomenon, produced by the same processes across many different star systems, then our formation models are missing something fundamental. A process capable of producing gaseous orbital bodies should appear in our simulations of how planetary systems evolve, and it doesn't, not yet. That gap between what the universe does and what our models predict is the most important gap in science. It's where the next revolution lives. Personally, the thing that stays with me about this discovery isn't the science, it's the implication for scale and possibility. We have been studying moons since Galileo. We have sent spacecraft to Europa and Titan and Enceladus. We have mapped, measured, theorized, and cataloged. And in all of that time, across all of that work, we somehow missed an entirely new category of object sitting in the outer solar system, waiting for an instrument sensitive enough to finally see it. The universe doesn't run out of surprises. It never has. And every time I think we're close to a complete picture, something like this arrives and reminds me how many of that picture are still blank.
Webb isn't finished. Its mission lifetime extends for years, and every new pointing reveals something the previous generation of telescopes couldn't see. The gaseous moon data is still being analyzed, debated, peer-reviewed, refined. We are at the very beginning of understanding what these objects are, how they form, and what they mean. But the fact that they exist, that much the light itself has already told us. If gaseous moons have reshaped our understanding of what orbits planets, then the next question is even larger. What does the architecture of the entire universe actually look like when we have instruments capable of seeing everything? In the next investigation, we turn Webb's golden mirrors toward the cosmic web itself, the vast network of filaments connecting every galaxy cluster in existence, with colossal voids stretching between them where almost nothing should exist. But something does exist there, and what it is may be the strangest discovery Webb has made yet. That mystery is already waiting for you.